Welcome back. Now we will see how to model a tank. Let me consider a tank this way. Say this is a tank. In this is the input and this is the output. In the output terminal I have connected a resistance R and this is my final output. You see, if this input is kept constant, the level will settle down at a particular value. Okay, if input flow rate equal to output flow rate, if this is the situation, then there will be a certain height that will not change. Now for simplicity I will consider one resistance over here also. Okay, so you may consider it is a valve resistance. Till now we have told it R as a resistance, you may consider it is a valve. So it may be a control valve, it may be a load valve, anything. Now you see this valve, say if I consider it as R1, say R1, then this R1 may be a control valve, and this if I consider it as R2, or instead I am just considering as R, this R may be a load valve, because it is the load is applied to this valve R. So I am considering it as load valve. Now if I consider this Q is being added with a quantity Q I, that is input flow rate, and the output flow rate is changed by this Q naught. Okay, so what is this Q's? These are the steady state values. If the value is maintained at Q, capital Q, then the level will be same. Now I have changed this Q by Qi, this input is changed, so accordingly this Q naught we have obtained. Now we will find out the values. Okay, so just consider, if capital Q is the input and output, if it is being constant, then the height is being constant at capital H, and if Qi is added with, it is added with capital Q, then this small height h is also added with capital H. Now the value of Q may be given as KL into H. Say it is equation number 1. Now for a laminar flow rate, you just remember, for laminar, I am not writing everything. Laminar flow, for laminar flow, this RL will be, or R laminar you can write RLA. Laminar flow is given by dH by dQ. dH means change in height or level, and dQ is the change in flow rate, is given by 1 divided by KLA. What is KLA? We will see, and it is given by H divided by Q. This is equation number 2. Now in the laminar flow, the resistance RLA is constant and is analogous to the, or it may be considered to be analogous to the electrical resistance. This equation is valid for laminar flow. Now in next we will consider the turbulent flow. So in case of turbulent flow, we will write for say B, for turbulent flow we will write Q equal to KTU into square root of H. This is the expression for turbulent flow at steady state again. This capital Q is the at steady state. Equation number 1 also you can remember Q equal to KL into H, but in case of turbulent flow this square root term will come, and this KL is a constant, KTU is constant. What is KL? KL is for constant for laminar flow and KTU is constant for KL or KLA, laminar. L stands for laminar, you can write LA, you can write completely K laminar, no problem. Okay, here also you can write KTU or KT or K turbulent, anything you can write. This is the constant, flow constant. Okay, now you come to RT, say RTU, resistance of turbulent flow will be DH DQ. Say this is equation number 4. Now from equation number 3 we can write DQ equal to KTU into half into h to the power minus half into dH, and dH dQ will be given as KTU divided by 2 square root of H inverse. If you further process this, you will get TU equal to 2 square root of H square root of H divided by, you are putting the values, by Q, you will get 2H divided by Q. This is equation number 5. Remember this equation number 5. Now after equation number 5 you can write consider equation number 4 as well as equation number 5. In equation number 4 we have written RT is equal to dH by dQ, and in equation number 5 we have found the value of dH by dQ. So 4 and 5 cumulatively will give us the value of R turbulent equal to 2H by Q. Say it is equation number 6. You can very well find out the equation number 4 and 5. From that you can find out the values of RTU. So you have found out the turbulent flow resistance. Now this here whatever we have considered, again I am telling, this Q is a capital Q, remember, is a steady state liquid flow rate. Steady state, it is also liquid flow rate. QI is also liquid flow rate, but Q, capital Q, is the steady state liquid flow rate, and capital H equal to steady state height or head, you can write head, is called steady state head, means liquid head, and it is steady state liquid flow rate. Okay, and this K laminar equal to constant and K turbulent is also constant. Okay. Hope you have understood this. So, this equation number 6 as well as the equation number 2 must be considered for 6 will be considered for turbulent flow and this equation number 2 may be considered for laminar.